Today we are going to jump straight into a university physics problem. This problem is one of the harder ones because it combines two different sections. So we'll talk about that in a minute. Let's take a look at the question. An object orbits a planet with an elliptical orbit. The mass of the planet is given as 5.1 times 10 to the power of 30 kilograms. The smallest and largest orbital radii in the elliptical orbit are 1.2 times 10 to the 11 meters and 1.7 times 10 to the 11 meters. What are the speeds of the object at these points? So this one is a bit different than the questions we normally see because we have an elliptical orbit. Our speed is going to be changing and our radius is going to be changing as we move around that orbit. So let's start by drawing a picture of what we have here so we can sort this out. We've got R1 and our V1. So R1, we're going to call that the smaller radii, and R2 will be the larger one, which is associated with V2. We've got the mass of the planet, and we've got our gravitational constant. All right, so the first thing we can do for this one is use our conservation of angular momentum. We know that the angular momentum should be conserved at any 2 points in our elliptical orbit. And instead of using the cross product equation for this, we can use a bit of a shortcut. Because the radius is perpendicular to the direction of our velocity, we can use that the angular momentum is just r times the linear momentum. So normally you'd have to use the cross product, but since we are perpendicular, we can use this shortcut equation. Now the linear momentum is going to be the mass times the velocity, so that'll show up on both sides of the equation. And that mass that we're talking about here is going to be the mass of the object, not the mass of the planet. But since that shows up on both sides of the equations, we can go ahead and cancel that out. Now, we have two unknowns in this equation. We don't know what V1 is, and we don't know what V2 is, but that's okay. We will rearrange this for V2 written in terms of V1 and the two radii. So we'll leave that alone for a minute and call that equation number 1. And anytime we have one equation with two unknowns, we have to remember that there needs to be another equation here. And the next equation that we're going to have is our conservation of energy. So when we're looking at the conservation of energy, we're going to want to look at the kinetic energy and the potential energy. Our kinetic energy plus our potential energy at the first state should be equal to our kinetic energy plus the potential energy at the second state. So that total amount of energy is going to stay constant as we move around the elliptical orbit. It's going to shift between kinetic and potential as it moves around. For the kinetic energy, we have 1/2 mv squared. And for the potential energy, because we're talking about orbits, we're out in space, we're going to use the potential energy as big G, our gravitational constant. That capital M is the mass of the planet, and then the little m is the mass of the object, and that will be divided by our radius. And with this equation, there's a negative sign in there, so be careful of that. Once we expand that out for both sides, we'll see that the mass of the object shows up in all of the terms here, so we can do the same thing as before and cancel that out. Now we have a second equation with those same two unknowns. So now we've got two equations, two unknowns. We can start putting those together. When we combine those two equations, we're going to take our equation for V2 and we're going to substitute that into our second equation. And now once we have this, let's start to clean this up. So let's bring everything that has V1 over to the left side of the equation and everything that does not have V1 over to the right side of the equation. And then we can factor out that V1 squared. And we can divide the right side of the equation by everything in those big brackets here. Now to get V1 by itself, we'll just have to square root this whole thing. So we end up with kind of an ugly equation, but if we look at this equation, we've got capital G, which is our constant, we know that. We've got capital M, which is the mass of the planet, we've got that. And the other two pieces are R1 and R2, and we have both of those. So that means we can go ahead and plug our numbers in. And when we do that, we get that V1 is equal to 5.76 times 10 to the 4 meters per second. Now our last step is to go back to V2 because we need to solve for that one using the V1 that we just solved. So we go back to equation 1 and plug in our numbers there, and we'll get that V2 is 4.07 times 10 to the power of 4 meters per second. Okay, so let's recap. If we see an elliptical orbit, that should be a heads up that we can use two equations for that. That's our conservation of angular momentum and conservation of energy. And just keep in mind that anytime you see something where there's two unknowns in one equation, that means that there must be another equation that you can use for that situation. Okay, that's it for this one. Give us a subscribe if you want to see more of these videos. We're going to be posting more university physics questions with solutions. We're going to be aiming for questions that are a little bit harder than what you normally see.